Good morning, everyone, and welcome to our Friday Happy Math Hour. For today's session, for those who are here for Math 1314, we will do linear and nonlinear systems of equations. So if you bear with us a little bit, we will have a link for those who are here for Math 1324. And let's see here. There we go. Now it's there. So we'll give a few seconds for those again for those of you who are here for Math 1324. You will find the link on the chat. Go ahead and click on that, and it will take you to the Math 1324. So then again, welcome all of you for joining us today on a Friday. So let's go ahead and get started. Um, So what is a linear system? So a linear system is equations that are in this form: ax plus by is equal to c. And if we were to um, draw these lines or draw these equations, we would see that we would be graphing lines. Okay, so a linear system is made of more than one linear equation. Okay, so um, a solution for a linear equation is going to be an ordered pair that the x and y value satisfies both of the equations. When we substitute the x and y value for both, or for any of the equations given, it'll give us a true statement. Okay, so a solution set is a set of all ordered pairs that satisfy both equations. Okay. All right, so a system a system can be with not only linear equations, but it also can be with nonlinear equations. And we're going to see several examples of these as well. Okay, so there are three ways to find solutions to systems. The three ways are the substitution method, the elimination by addition method, and graphing. So the solution is the intersection of the graph. So let's look at first graphing. Okay, so if we were to look at graphs, okay, if we look at this first left-hand one, we would see that we have two lines, right? We would have these two equations, and where these two lines intersect, this would be our solution point, right? That this point where they intersect 2, 0 is true for both of these. If I would plug in 2 for the x on this first one and 0 for the y, I would get a 1. If I would put 2 for the x on the second equation and 0 for the y, I would get the 2. Okay? So again, graphing will have us solve these systems. So on this middle one, if you see we have a linear equation, but we have it graphed with a nonlinear equation. This is a parabola, right? So we have a quadratic with a linear equation. So in this particular example, our line crosses at 2 points of our parabola. So at these 2 points, at 2, 1, and at 0, -1, this would be our solution set, right? That we have two answers where these two graphs intersect. And then we have this last example here. Um, uh, and actually, we have this last example here where we have a linear equation with another quadratic equation, but we see that these two graphs do not intersect, right? So this is what we call a no solution. Okay. All right. So let's first practice determining if our order pair given is a solution of a system. So in this particular example, hopefully we all can see that we have two linear equations. We have 2x minus y is equal to 4 and 8x plus y equals to -9. Now, how do I know that these are two lines? I look at the exponent of the x, right? Since the exponent of the x is 1, I know that these are linear equations. All right, so let's do A. Um, let's find out if the x value for 0 and the y value for -4 satisfy both of these equations. So what to do this, we're going to go ahead and replace it with the first one first. 2x minus y equals to 4. I'm going to replace the x with a 0, the y again with the -4. And when I do this, I see that um, it gives me a true statement. 4 is equal to 4, right? When I do the math here, um, it's true. But let's go ahead and verify. We have to check the second equation. Okay, so when we plug it into the second equation, again, x equals to 0, y equals to -4, we see that we have a false statement. On the left, we had -4, and on the right, we had a -9. So this is a false statement. So um, 0, -4 will not be a solution for this. It has to satisfy all of the equations given. So since it fails one, um, it's not a solution. Okay, so let's go ahead and do B. Let's do the same thing. We'll go ahead and plug it into the first equation. The x would be -1/2. The y would be a -5. And we see that we have a true statement. When we do the math, we have 4 equals to 4 again. Well, that's a small coincidence. Okay, that doesn't always happen. All right, so when I plug it in to the next equation, the second equation, the 8x plus y equals -9. Again, when I plug in the -1/2 for the x, the -5 for the y, oh, I see that on this one, I also get a true statement. So since I had a true statement for both, then, oops, -1/2 and -5 is a solution for this system. Okay. And again, what did this mean? At this point, -1/2 and -5 is where these two lines intersect. On this particular one, these two lines don't intersect, so that's why it's not a solution. All right, so to solve the system equations using substitution and elimination method, let's look at both of them together. That way you can see the beauty of both, okay? So let's start with the substitution. Now, the name substitution, the name says it all, okay? To do the substitution method, what you'll have to do is you have to solve one of the equations for one of the variables. It doesn't matter which one, it could be the x or the y. And once you solve for that, you're going to substitute that solution to the other equation, and then you'll solve for the unknown variable. So again, to better see it, let's go and do the example. So for me, it doesn't matter. I'm just going to choose the first equation, which is the x plus y equals to 4, and I'm going to solve for one of the variables. Now, for me, again, it doesn't matter which one you solve for. I'm just going to solve for x. So all I had to do was move the y to the other side by subtracting y on both sides. So I have this. X is equal to 4 minus y. So what I'm going to do now, I'm going to substitute that into the second equation. Everywhere I see everywhere I see x, I'm going to plug in 4 minus y. So if you see here, I have it in red. So where x is 4 minus y, then I have a minus y is equal to 2. So then I'll combine my y's. I have minus 2y. Subtract 4 on both sides. I'm going to get a, let's see here, a minus 2. And then I'm going to divide by a -2. So it's going to give me the positive 1. So y equals 1. So now that I have one of the variables, I can substitute this y value into any of the equations. But what I'll do is, since I have the x already equal to my value that I want, I'm going to plug it into the red. Okay, so I'm going to do the if I would have done it here, so 4 minus 1, it would have given me the 3, x equals 3. But again, I plugged it into that first equation, the x plus y equals 4. So again, I did a little math again. Subtract 1 on both sides gives me that 3. Okay, so this is the substitution method. To do the elimination by addition method, just like the name sounds, we want to eliminate one of the variables by adding the two equations together. Once we eliminated one, then all we have to do is, once we have one variable, we substitute it to the other one, and we'll get our other unknown. So let's go ahead and do it. So for my my elimination method, I'm going to choose a variable to eliminate. Okay? So in my case, I want to eliminate the y's. And the reason why I want to eliminate the y's is because it's very easy. I don't have to do any extra work, but just add them together. You see here, both the y's have opposite signs and they are the same value. They're both a value of 1. So if I add them together, I'll eliminate them. Okay? So let's go ahead and do that. I'm going to get equation 1, which is x plus y equals to 4, and I'm going to add it to x minus y equals to 2. So when I do this, I have 2x is equal to 6, and then to solve for x, I'm going to divide by 2 on both sides. X is equal to 3. And you see it's the same x that's from the solution set from the left, right? So then all I have to do to get the y value, let's pick the other equation just so you could see that it gives us the same answer. So if I would have put 3 here, so to solve for y, I subtract 3 on both sides, I get a negative 1, but I have to multiply a negative on both sides. That's going to give me that positive 1. So the solution set for this again is 3, 1. So these are the two ways that we can do it algebraically to solve linear systems. Okay, it's the substitution and elimination method. All right, so let's go ahead and look at another example, and let's choose any method. So in this particular problem, let's see. Let's go ahead and use the substitution method. And the reason why we want to use the substitution method is because the homework already did half of the work for us. They already solved for one of the variables. They solved for y here. So since they solved for y, let's go ahead and do substitution method. So what I'm going to do is everywhere I see y on the second equation, I'm going to replace it with 2x plus 3. Okay, so which is what I've just said right now. So here we are. So we have x plus 2 times 2x plus 3 is equal to negative 4. So we're going to simplify to solve for x. So the first thing I have to do is distribute by 2. Okay, so once I distribute that 2 to the 2x plus 3, I get 4x plus 6. I'm going to combine my like terms. So now x plus 4x is 5x. I'm going to move the 6 to the other side by subtracting 6 on both sides, and I get a negative 10. So to solve for x, I'm just going to divide by 5 on both sides. So x is equal to negative 2. So now that I have one of the variables, I'm just going to plug it into that first equation again. Okay, so here, if I substitute it back to that first equation, we have 2x plus 3 equals y. Again, 2 times the negative 2 will give me a negative 4. Negative 4 plus 3 will give me a negative 1. So y is equal to negative 1. So my solution for this is negative 2, negative 1. And again, to solve for this one, I use the substitution method. Okay. All right, let's look at this one again. And if you see this one, they did half of the work for us already. The second equation, they solved for y. So let's go ahead and use the substitution method again. All right, so once we have our equation, 3x minus 2y, I always have to choose the other one, okay? So 3x minus 2y is equal to 7. Everywhere I see y, I'm going to plug in this 2x minus 3. Okay, so here we are. 3x minus 2 times 2x minus 3 is equal to 7. Then I'm going to simplify first by distributing that negative 2 to that 2x minus 3. So a negative 2 times a positive 2x is a negative 4x. A negative 2 times a negative 3 gives me a positive 6. Let's combine up my like terms. 3x minus 4x is a minus x. Move the 6 to the other side by subtracting 6 on both sides. So 7 minus 6 is 1. So multiply by a negative on both sides to get a positive x. So x is equal to negative 1. So now that I have one of the variables, I'm going to substitute it to any of the equations. Okay, so again, in my case, I want to substitute it to that second equation. So we have y is equal to 2 times the negative 1 minus 3. So y is equal to minus 2 minus 3. So y is equal to negative 5. So my solution set for this problem is from negative solution set is x is equal to negative 1 and y is equal to negative 5. Okay. All right. So let's see here. All right, let's look at another problem. It's a little bit more complicated. And again, they're asking us, or they're letting us solve any method that we want. So let's see here. Let's choose the elimination method on this one. Okay, so to choose the elimination method, again, if you recall, we need to add these two together to eliminate one of the variables. So what I want to do is I want to eliminate the x. So um, one of the nice things is both that the x values here have opposite signs. So what I have to do is just find a common number that, or the same number for those two to eliminate, right? So a positive with a negative will become that 0. So we want to find the least common multiple between 2 and 5. So the least common multiple between 2 and 5 will be 10, right? So what we want to do is we want to multiply a 5 to equation 1, because that will give us the 10. And we want to multiply a 2 to equation 2, and that will give us the negative 10. But again, we got to keep in mind, we are dealing with equations. So when I multiply this 5, I have to multiply to the whole equation, to both sides of the equation. So here, when I multiply the 5 times 2 is going to give me the 10x. 5 times the negative 7 is going to give me the negative 35y. And the 5 times 3 is 15. Okay. In order for me to have a balanced equation, I had to multiply this 5 again to both sides. So let's do the same thing for the 2 for the second equation. 2 times the negative 5x gives me the negative 10x. 2 times the 3y gives me the 6y. And then 2 times 7 gives me the 14. So now, when I add these two equations, we see here 10x minus 10x gives me 0. I just eliminated the x value. And then let's add the y. Minus 35y plus 6y will give me a negative 29y. And 15 plus 14 is 29. So to solve for y, I'm going to divide by a negative 29 on both sides. So y is equal to negative 1. So now that I have one of the variables, again, to get my other one, I'm just going to substitute it to any of the two equations. Okay, it doesn't matter which one. Again, so on this one, I'm going to choose that first one. That is the easiest one. So we have 2x minus 7 times the negative 1 is equal to 3. Negative 7 times the negative 1 is a positive 7. Move the 7 to their side by subtracting 7 on both sides. This gives me a negative 4. Divide by 2 on both sides. X is equal to negative 2. So my solution set for this problem is negative 2, negative 1. Okay. Again, if anybody has any questions, please feel free to unmute your mic and ask me, okay? All right, let's solve for this system of equations, okay? And then again, let's go ahead and do the elimination method again. And let's go ahead and eliminate x again, okay? So again, I want to find the least common multiple between 2 and negative 4. And again, that would be that 4, right? So all I have to do is now multiply just 2 to that first equation. And I'm going to leave the second equation alone, okay? So I'm going to multiply the first equation by 2. So when I do that, I get 4x minus 10y equals 12. Again, my least common multiple was 4, so I don't have to do anything to that second equation. So now I'm going to add them together. So when I add 4x minus 10y equals to 12 with minus 4x plus 10y equals to negative 1, 4x minus 4x is 0. Okay, 10y, negative 10y plus 10y is 0. 12 minus 1 is negative 11. Uh-oh. We have a problem here because we have a false statement. 0 is not equal to negative 11. So when this happens, what this means is that these two lines never intersect. So because we had a false statement here, the system is called an inconsistent system. That's what it means when the two lines never intersect. So hence, there is no solution for this system because these two lines never intersect. Okay, so we didn't do anything wrong. This will happen. Okay, so let's look at a word problem. Okay, The given amount of an annual interest is earned from a total of $9,000 invested in two funds, paying simple interest. Write and solve a system of equations to find the amount invested at each given rate. Okay, so we have an annual interest rate of $380. The first investment has a investment rate of 2%. The second investment has an investment rate of 6%. So to solve for this, we have to find the two funds, and let's just call them A and B. Okay, let's call investment A, investment B. And we know that together they need to add up to a total of $9,000. So this is where we're going to get our first equation, okay, with that first piece of information. And the second equation we're going to get by letting A, the investment, be the 2% and investment B be at the 6%. So let's go ahead and do this. Let's go ahead and write these guys out. Okay, so the first one is easy to write. Okay, they want us to have a total investment of $9,000 between investments A and B. So investment A plus investment B should equal this $9,000. Now, to get the total interest based on our interest rates, we would need to have the interest multiplied to investment A plus the interest of B multiplied to the B, and this should give us a total interest rate of 380, which was given here with our annual interest, right? So now we see we have two linear equations. So now we are able to solve any way we want. And I think the best way is to go ahead and do, um, well, before that, um, I know some of you guys might not like the decimals, so let's go ahead and get rid of the decimals so we can have a prettier equation. So to get rid of the decimals, I want to move the decimals 2 units to the right, so I'm going to multiply it by 100. Okay, so I'm going to multiply equation 2 by 100, and when I do that, I have a much nicer equation. 2a plus 6b is equal to 38,000. Okay, so now let's go ahead and do the elimination method. So to do the elimination method, I'm going to eliminate the A. So what I'm going to do is I'm going to multiply the first equation by a -2. Okay. So when I do this, I get -2a minus 2b is equal to -18,000. I'm going to add this equation to equation 2, which is 2a plus 6b is equal to 38,000. So let's go ahead and do this. -2a plus 2a got eliminated, 0. Minus 2b plus 6b is 4b, and -18,000 plus 38,000 is 20,000. Okay, so to solve for b, I'm going to divide both sides by 4. So b is equal to 5,000. So now that I have b, I can plug it into the first equation, or call it back substitution. And again, I'm going to plug it into the first equation. And I chose the first equation because it's the easiest equation to plug in the numbers with, right? But you can plug it into any of them. It'll give us the same answer, either equation you choose, okay? So here I'm choosing the first. So a plus 5,000 is equal to 9,000. So to solve for a, all I have to do is subtract 5,000 on both sides. So a is equal to 4,000, okay? All right. So what we've seen so far was the ones that were linear systems, but we also are going to have homework problems that deal with nonlinear systems. And if you recall, is those problems that we did with a parabola and a line. Okay, but what are also other nonlinear systems that we've been working with in this class? Maybe you can get a circle and a line, or maybe you can get a circle and a parabola, or maybe you can get two parabolas, or maybe you can get two circles. Okay, so you'll be asked to solve these types of equations that are non-linear systems, that are not just lines. Okay, so let's look at this one. Solve the system of equations using any method. So if we see here, we do have our first equation because that x has an exponent of 2, we're dealing with a quadratic. The second one is a linear equation. So um, let's go ahead and use the elimination method for this one. Okay. And the reason why, again, I'm choosing to do the elimination method and I want to eliminate the y's is because this one's easy to do. If I just add these two equations together without doing any work other than the addition, I'm going to get rid of the y's. Okay, so let's go ahead and add these two equations together. So when I have x squared minus y equals to 0, added with 4x plus y equals to 0, okay, if you see here, the y's got canceled, but I got an x squared plus 4x is equal to 0. Now to solve for x, let me just go ahead and factor this guy out. But if you see here, I have a quadratic, but let me see, how did I do this? Yeah, let me just factor it out. Okay, so I do have a quadratic, but I can solve for the x by just factoring. So if I factor out the x from the x squared plus 4x, it gives me x times x plus 4 is equal to 0. So when I have a product of two numbers, the only way that I can get 0 is if either x is equal to 0 or the x plus 4 is equal to 0. So again, this one's easy. X is equal to 0, but to solve for this other x, I subtract 4 on both sides, so x is equal to negative 4. Okay, so I have two values for x. Okay, so to get my y value, I'm going to have to solve either of these two equations twice, one with a 0 and one with the negative 4. Okay. So let's start with our back substitution with x equals to 0, and I'm choosing the second equation. Okay, so I have 4 times 0 plus y equals to 0. So 4 times 0 is 0. So y is equal to 0. So that's one of the solutions. Okay, let's go ahead and choose now the negative 4. So 4 times negative 4 plus y equals 0. So 4 times the negative 4 is a negative 16. Add 16 on both sides, so y is equal to 16. So here, our solution set is 0, 0, and negative 4, 16. So what this means is our line crosses our parabola at two places, right? At the 0, 0 and negative 4, 16. Okay. Any questions? All right. Um, let's go ahead and do this one. Um, let's go ahead and also use the elimination method for this one, um, even though we have the same sign, but it would be easy to make one of those positives, right? Just multiply by negative on one of those two equations. So I'm going to multiply negative 1 to the first equation. Again, it didn't matter which one. I'm just picking the first equation. So if I multiply negative 1 to the first equation, I'm going to get a negative x plus y equals 5. Now I'm going to add it to the second equation. So my second equation is the x squared minus y equals negative 6. So you see here my y's canceled, and I'm left with x plus x squared is equal to negative 11. Again, we know that this is a quadratic, so we're going to move everything to one side, okay? So when I do this, moved everything to the left, okay? Made it much nicer. And I also put it in our convention format in descending order. So we have x squared plus x plus 11 is equal to 0, okay? So again, since we have a quadratic, let's go ahead and use the quadratic formula since I know I couldn't factor it. But what we see here is that inside the radicand here, we get a negative 33. Now I know we've been dealing with imaginary numbers, but this would give us an imaginary number, but it's not a true solution. It's not a positive value. So what this is saying is that this is an inconsistent system, meaning that my line does not intersect my parabola. Okay. Um, questions? All right. Uh-oh. Let's look at this system of equations, right? So if you see here, none of these two are linear equations, right? The first one, if you recall, we have a circle here. And then the second one, this one is a quadratic, right? So for us to solve for this one, I think we're going to need to we can use the elimination method. So let's go ahead and do that. Let's eliminate the x. So To eliminate the x, I'm just going to multiply the first equation by a -3. Okay, so when I do this, when I multiply -3 to the first equation, it's going to give me a -3x squared minus 3y squared equals to -75. I'm going to add this to equation 2, which is 3x squared minus 16y equals to 0. So here we go. So let's go ahead and add them. So when we add it, we have -3x squared plus 3x squared. My x variable got eliminated. We have a -3y squared minus 16y. These two are not like terms, so they're just separated. And -75 plus 0 is a -75. So we have a quadratic equation again. So I'm going to move everything to one side. So we have -3y squared minus 16y plus 75 is equal to 0. So what I'm going to do is I'm going to use a quadratic equation because again, this one a little bit complicated to factor. So here, when I use my quadratic equation, I see that I have two answers. Um, when when I'm adding the 34 and when I'm subtracting the 34. So when I'm adding 34, I get -25 over 3. And when I'm subtracting the 34, I get y equals to 3. So now I'm going to do back substitution, but I have to use both of these two variables. Now I'm going to pick to substitute the first equation. I'm going to use the first equation to get the x value. So let's start with the easy one, with the 3, right? Y equals 3. So when I plug this in, x squared plus 3 squared is equal to 25. So 3 squared is 9. I'm going to subtract 9 on both sides. Gives me 16. So x is equal to plus or minus 4. So here we have these two solutions. X is equal to positive 4 and y 3, and the -4 for the x and the y 3. Okay? Now, if I were to plug in the -25 over 3 to the first equation again, we would see that this does not match, right? There's no way for us to solve this. So this would give us no real solution. Why do I say that's not solved? Because when I take the square root of a negative number, again, it's imaginary, so it means no solution. So again, for this graph, our quadratic is going to intersect our circle at these 2 points, at 4, 3 and -4, 3. Okay. And this is our solution set for 3 and -4, 2. Okay. Oh, I messed. This should be a 3, not a 2. Okay. All right. Let's solve this system using any method. Oh, let's see. Um, we have a situation here. We have an xy minus y equals 0, and we have a 3x minus 6y plus 17 equals 0. Hopefully you see that the second one is easy. We're dealing with a line, right? But this first one, for us to see what we're dealing with, let's solve for x first. Okay, so let's go ahead and solve for x. So to solve for x, I'm going to add y on both sides, and then I'm going to divide by y on both sides. So x is equal to 1 over y. Okay, so again, let's use our substitution method to replace this variable to our second equation. Okay, so everywhere I see y, everywhere I see x, I'm going to plug in this 1 over y. So let's go ahead and get rid of this fraction by multiplying by y on the entire equation, just for it to be a little bit nicer. Okay? So when I do this, y divided by y is 1, giving me 1 times a -6y times y. Okay, did you have a question? Okay, all right. Um, So a -6y times y will give me a -6y squared, and the y times 17 gives me the 17y equals to 0. Okay, so now we're going to solve for y, and we see that we have a quadratic again. So we have a negative 6y squared plus 617y plus 3y is equal to 0. Again, let's go ahead and use our quadratic equation to solve for that y variable. And we see that we have two solutions again. When we are adding the 19 and when we're subtracting the negative 19 from the square root of 361. Okay, so the square root of 361 is going to give me 19. All right, so let's do back substitution. And again, I'm going to go ahead and pick the first equation, or the equation which I have it set up to that I've solved for y already. Okay, so here, x times the negative 1, 6 minus 1 is equal to 0. We get a negative x over 6 is equal to 1. I moved the negative 1 to their side by adding 1 on both sides. And then now I'm just going to multiply a negative 6 on both sides. So x is equal to negative 6. Okay. Now let me do it again for y equals 3. So when I do this, I have x is equal to 1/3. So my solution set for this is negative 6 and negative 1/6 and 1/3 and a positive 3. Okay. And I am finished. Finished with a lot of time ahead of schedule. Does anybody have any questions? Again, if you joined our presentation late, I want to remind you that all you need to do, if you are logged in right now, is click on this little symbol here, the arrow with a box pointing down. If you click on that, you'll be able to download the presentation. Um, Again, thank you for joining us. Our semester's almost over. Hang in there, guys. Okay. I'll pass it back now to our collaborators. Thank you all for joining me today.
Okay, thank you so much, Mr. Carrizales. This was a wonderful presentation on solving systems of equations by adding, by substitution. And if you have any questions, please feel free to ask any questions. If not, please join us next week. We will have our, well, not next week. Next week is Thanksgiving, so we won't be having a Happy Math Hour. But the following week, on December the 1st, we will have, for Math 1314, we will have basic operations, and Math 1324, basic concepts of probability and permutations. The student success topic for December the 1st is Learning Express. So join us next week at 11 o'clock, and we will see you if you don't have any questions.